Hello students, by now you are familiar with the basic solid shapes like cubes, cones, spheres, cylinders, etc. Now in our day-to-day life when we come across various objects, most of the objects are in the shape of combination of these basic solid shapes like combination of a cylinder and a cone, or a combination of a cylinder and a hemisphere, etc. So in this session we deal with such kind of solids, the solids which are in the form of combination of two or more basic solid shapes. So we start with exercise 17.4. We are going to solve question number 3 now. From a cube of edge 14 cm, a cone of maximum size is carved out. Find the volume of the remaining material. So here this is the diagram. From a cube of edge 14 cm. This is a cube of edge 14 cm. From that a cone of maximum size is carved out. So when we carve out a cone of maximum size, the height of the cone will be equal to the edge of the cube, and the diameter also will be equal to the edge of the cube. So diameter is equal to the edge of the cube. That means radius will be equal to half of the edge. So radius will be equal to 7 cm and height will be equal to 14 cm. Height is equal to edge of the cube. Now we have to find out the volumes of the volume of the remaining material. So for that we need to find out the volumes of both the solid figures. So first of all we find out the volume of the cube. Volume of cube is equal to, we know that it is edge cube, that is 14 cube. So that is equal to 2744. This is the cube of 14 centimeter cube. Now we have to find out the volume of the cone. For that we already found out the height and the radius. So radius of cone R is equal to 7 centimeter. Height of cone H is equal to 14 centimeter. Now volume of cone is equal to 1 by 3 pi r square h. That is equal to 1 by 3 into value of pi, that is 22 by 7 into r square. 7 into 7 into h, that is 14. That is equal to 7 and 7 can be cut. Now 22 into 7 into 14 divided by 3. By calculating it, you will get 718.67 centimeter cube approx. This is an approximate value. Now this is the volume of the cone. So now we can find out the volume of the remaining material. Volume of remaining material is equal to volume of cube minus volume of cone. That is equal to volume of the cube is 2744 centimeter cube minus volume of the cone is 718.67 centimeter cube. That is equal to, by subtracting this we get 2025.33 centimeter cube approx. So this is the volume of the remaining material. Now question number 7. A cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter that the hemisphere can have? Also find the surface area of the solid. So here this is the diagram. A cubical block of solid and a hemisphere, it is surrounded by a hemisphere. So it is asked that what is the greatest diameter that the hemisphere can have. So the greatest diameter, that we can see that the diameter of the hemisphere is equal to the edge of the cube. So the greatest diameter that the hemisphere can have is equal to the edge of the cube, that is 7 cm. So the radius of the hemisphere will be 3.5 cm. So here we can write edge of the cube is equal to 7 centimeter. Now, diameter of the hemisphere is equal to edge of the cube, that is 7 centimeter. Now, therefore, radius R is equal to 7 by 2, that is equal to 3.5 centimeter. Now, we have got the dimensions of cube and hemisphere. Now, we have to find out the surface area of this solid, total surface area of this solid. For that, what we have to do is we have to find out all the surface area, both the surface area of both the solid figures which can be seen outside. So, that will include the surface area of the cube and the curved surface area of the hemisphere, and then from that we have to subtract the base area of the hemisphere. So, the total surface area of the solid is equal to surface area of cube plus curved surface area of hemisphere minus the base area of the hemisphere, that part coincides with the with one of the edge of the some part of one of the edge of the cube. Therefore, this part we have to subtract because that part cannot be seen outside. Therefore, that part does not include in the surface area. Therefore, that part we have to subtract. Therefore, we write minus base area of hemisphere. So, surface area of cube, that is 6a square, that is 6 into 7 square, plus curved surface area of hemisphere, that is 2 pi r square, 2 into 22 by 7 into r square, 3.5 into 3.5 minus base area of the hemisphere, that is pi r square. So, 22 by 7 into 3.5 into 3.5. So, that is equal to here 6 into 49 plus, so here we can take out 22 by 7 into 3.5 into 3.5. So, 22 by 7 into 3.5 into 3.5 in bracket. Here we have 2 and in this we have taken outside one of this. So, we have 1. Therefore, 1 time 22 by 7 into 3.5 into 3.5. So, 6 into 49 is 294 plus 22 by 7 into 3.5 into 3.5. When you multiply this, you will get, okay, what we can do is that 3.5 and 7 can be cut, here will be 2, and here 2 and 22 can be cut, here will be 11. 11 into 3.5, that is 38.5. So, that is equal to, we add both of this, that is 332.5 centimeter square. This is the total surface area of the given solid. Now, question number 11. An exhibition tent is in the form of a cylinder surrounded by a cone. The height of the tent above the ground is 85 meter and the height of the cylindrical part is 50 meter. If the diameter of the base is 168 meter, find the quantity of canvas required to make the tent. Allow 20% extra for folds and stitching. Give your answer correct to nearest meter square. So, an exhibition tent is in the form of a cylinder surrounded by a cone. So, this is the cylindrical part, this is the conical part, and the height of the tent above the ground. The total height of the tent is 85 meter. Height of the cylindrical part is 50 meter. If the diameter of the base is 168, the diameter of the base is 168, that means this diameter is 168. Now, the diameter of the base of the cone is also 168 meter. That means the radius of the base we can find out. Radius of the base will be half of 168, that is 84 meter. Here also this is also 84 meter. This is the radius of both the base of both the cylindrical and conical part. Now the height of the cone is equal to total height minus the height of the cylindrical part, that is 85 minus 50, that is 35 meters. So these are the dimensions, given dimensions of both of these solid parts. Now we have to find out the quantity of the cloth required. That means we have to find the surface area of the total solid shape. So for that we need, for the conical part we need the slant height. We have to find out first of all the slant height of the conical part. So let us write diameter of base of both the solids. Both the solids is equal to 168 meter. Therefore, radius R is equal to 168 divided by 2, that is 84 meter. Now, height of cylindrical part, height of cylinder is equal to 50 meter, or we can, let us take it as H1, that is equal to 50 meter. Now, height of cone, that is H2, is equal to 85 minus 50. 85 minus 50, that is equal to 35 meter. Now we have to find out the slant height of the cone. For finding out the surface area of the cone, we need to find out the slant height of the cone. This is slant height. We can obtain it by using Pythagoras theorem. So slant height of the cone L is equal to root of 84 square plus 35 square, that is equal to root of 756. This is the square root of square of 84 plus 35 square, that is 1225. That is equal to root of 8281, that is equal to 91. We can find out the square root by using long division method. Now, so the slant height is equal to 91 meter. Now, the surface area of the solid. Is equal to the curved surface area of the cylinder plus curved surface area of the conical, curved surface area of the cone. So, curved surface area of cylinder plus curved surface area of cone. Now, curved surface area of the cylinder is, this is the curved surface area, that is equal to 2 pi r into h. So 2 into 22 by 7 into radius of the cylindrical part, that is 84 into height of the cylindrical part is 50, plus curved surface area of the cone. So that is equal to pi r, that is 22 by 7 into radius of the cone is also 84. R is 85 into R into L. Slant height, that is, we have got the slant height as 91 meter. So slant height is 91 meter. So 22 by 7 into 84 into 91. Now here 7 and 84 can be cut, that is 12. Here 7 and 84, again 12. Now here also for convenience we can take out 2 into, we can take out 22 into 12 outside. 22 into 12 is common in both the terms. Therefore, we can take out 22 into 12. So 22 into 12 in bracket. What remains is 2 into 50 here, that is 100 plus 91. So 191 is given. So that will be equal to 2 into 22 into 12 into 100 plus 91. That is equal to 264 into 191. That is equal to 50,424 meters square. So this is the area of surface area of both the solid shapes. So here this is the surface area. Now it is also given that allow 20% extra for folds and stitching. So including that we have to find out the area of the quantity of the cloth required. So we have to add 20% of the obtained surface area to find out the quantity of the cloth required. Therefore, total quantity of cloth required is equal to the surface area obtained, that is 50,424 plus 20% of 50,424, that is 20 by 100 into 50,424. So that is equal to 50,424 plus, by calculating this we get 10,084.8. So that is equal to 60,508.8 meter cube. It is, we have to find it out in approximate meter square. Here meter square. So approximate nearest meter square we have to find out, that is 50,509 meter square. Now question number 12. From a solid cylinder of height 30 cm and radius 7 cm, a conical cavity of height 24 cm and base radius 7 cm is drilled out. Find the volume and the total surface area of the remaining solid. So here it is the diagram. From a solid cylinder of base radius 7 cm and height 30 cm, a conical cavity of same radius and height 24 cm is carved out. We have to find out the volume and surface area of the remaining solid. So first of all, let us find out the we can find out the volume. For that we have to write down the dimensions. Now radius of cylinder and cone, both the radius are equal, therefore they can be written together. R is equal to 7 cm. Now height of cylinder can be taken as h1. h1 is equal to, height of cylinder h1 is equal to 30 cm. Height of the cone h2 is equal to 24 cm. Now volume of the remaining solid. Solid is equal to volume of the cylinder minus volume of the cone. Volume of cylinder minus volume of cone, that is equal to volume of cylinder is pi r square h. Pi r square h1 we can write minus 1 by 3 pi r square H2. That is equal to value of pi is 22 by 7 into radius. R is 7 into H1. H1 is 30 minus 1 by 3 into 22 by 7 into 7 into 7 into 24. So 7 and 7 can be cut, and here also 7 and 7 can be cut. 3 and 24 will be cut and it will be written 8. 22 into 7 is common, therefore we can write 22 into 7 inside the bracket. Here what is remaining is 30. After 22 into 7 we have 30 left here, minus 22 into 7 taking out we have 8 left here, that is 30 minus 8. So 22 into 7 is 154 into 30 minus 8 is 22, that is equal to 3388 centimeter cube. This is the volume of the remaining material. Now we have to find out the surface area of this solid. So for that, to find out the surface area of the solid, we have to add all the surfaces. Curved surface of the cylinder, one plane surface of the cylinder, and the curved surface of the conical part, conical cavity. So all these areas we have to add to get the total surface area. For that, we have to first of all find out the slant height of the cone. So slant height of the cone L is equal to, we have height and the radius. Height is 24 and radius is 7. So L is equal to root of 24 square plus 7 square, that is equal to root of 576 plus 49 equal to root of 625, that is 25. So the slant height is 25 centimeter. Now height of the cone is 24 centimeter, height of the cylinder is 30 centimeter, and the radius is 7 centimeter. Therefore, surface area of the solid is equal to of the remaining solid is equal to curved surface area of cylinder plus one base area of cylinder plus curved surface area of cone. So that is equal to curved surface area of cylinder, that is 2 pi r h1 plus base area of the cylinder, that is the base area of cylinder means the area of the circular base, that is pi r square plus curved surface area of the cone, that is pi r. So that is equal to 2 into 22 by 7 into h1. h1 is the height of the cylinder, that is 30 plus 22 by 7 into r square, 7 into 7 plus 22 by 7 into L, slant height, that is 25. So we can simplify, 7 and 7 can be cut. Here 7 and 7 can be cut, and here also we can cut 7 and 7. Now, in all the three terms, we have 22 as common, therefore we can take out 22. We do it for the convenience of the calculation. You can also calculate separately and you can add, there is no problem, but it will be complicated, I think, therefore we can take out 22 as common. So after taking out 22 as common, what remains here is 2 into 30, that is 60 plus Here after taking out 22 we have 7 plus here we have 25. So that is equal to 22 into 60 plus 7 plus 25, that is 92. And the product of 22 into 92 is 2024. So the total surface area of the remaining solid is 2024 meters square.